Good morning, this is Ms. Billerbeck, and we are going to talk about section 5.5, more about formulae. So remember, formulae is just formulas, is another way to say it, but when you're speaking Latin, you would say formulae because that's plural for formula. So an equation of motion of an object is given by the formula S equals ut plus 1/2 at squared. So it says find S when A is t. A is 10, U is 20, and T is 3. So in this situation, we would have S equals U is 20, T is 3. So we're just substituting it in, plus 1/2, and then A is 10, and T is 3 squared. Okay, so that gives me 20 times 3 is 60. Half of 10 is 5. And 3 squared is 9. So that's 60 plus 45 equals 105. So we're just doing substitution and then calculating it out. So 105 is our answer. But when it says find U, when we have that it's not set up for U, well, that's going to take a little more time. So we're given U with a certain conditions, so values. So let's first solve it for U. So we have S equals UT plus 1/2 AT squared. So we want to move the U term to this side. So we're going to use an additive inverse, UT minus UT here and a minus UT here. So we have minus UT plus S equals 1/2 AT squared. Now we're going to use an additive inverse here. We have a plus S, so minus S is your additive inverse. And we have negative UT equals, and this is 1/2 AT squared minus S. So we see, well, we don't have U by itself, and we have a negative T. So what we're going to need to do is use a multiplicative inverse now. So we're going to multiply by negative T to get rid of the T and that negative sign at the same time. And we do that to the other side. So the T's cancel, the U's cancel, the negatives cancel, so we have U equals, and we have a negative here which needs to be transferred to the top. So we have negative times a negative, so that's going to be a positive S minus 1/2 AT squared over T. Now we can finally substitute these conditions in. So they said A equals 6, S equals 203, and T equals 7. So let's put that in there. So S is 203. We have minus 1/2. And let me make some room here. T is 7. So A is 6, and T squared will be 7 squared over 7. So we have U equals, and then we need to figure out what that all is. So we have 203. Half of 6 is 3. So minus 3, and 7 squared is 49. 7 times 7. And then we have over 7. We're going to use the dry erase calculator over here to do 49 times 3. So that's 27. We have 12 plus 2 is 147. Oh, that's going to be nice. 203 minus 147 over 7. So we just subtract these two. So let's use the dry erase calculator again. So we have 203, 147. We're going to borrow one from over here, make that a 9, and get that one a 10. So we have 13 minus 7 is 6. 9 minus 4 is 5. So we have 56 over 7, and happy days, that's 8. So U is then 8. Okay? So after all that hard work, that's all U was 8. Okay? So let's go to the next problem. All right, so example 2, we have a formula is given by T equals U plus V and over U minus V. So this is the easy one, of course, and we're just solving for T. When U is 20 and V is 15. So we just use substitution. So we have 20 plus 15 and 20 minus 15. So that gives us 35 over 5, and that's just 7. So that was easy. Okay, now the hard part. We have this. So what we're going to do, we have to solve for V. That's going to be pleasant, huh? Okay, so we have U plus V over U minus V. All right, so I put a 1 here because if you remember, we learned about cross multiplying. So when we cross multiply, we have T times U minus V equals, and then this is just U plus V. All right, so see, it's going to be a little complicated, so fasten your seatbelts. So, okay, we have to distribute now. So we have T times U. So we have T, U, and T times negative V, so minus TV equals U plus V. Now our goal is to get these V's by themselves. So let's add a V, TV to both sides. And that gives me TU equals U plus V plus TV. Okay, so now I'm going to subtract U from both sides. And that gives me TU minus U equals V plus TV. All right, so we can pull the V out of both of these terms, and now you can probably start seeing how we might actually do this. We might survive here. So when we pull a V out of V, we have 1. Okay, so what I did is, remember how when you divide like that? Okay, so I pulled the V out, the V over V is 1. And then if I have TV and I want to get that out, isolate the V, I'm pulling the V out so those V's cancel. Okay, so that just becomes 1. So I have 1 plus T. So that's how I got the 1 plus T. All right, so that's still equaling TU minus U. So now we see we have this multiplying by the V, and we don't want it there, so we're going to use a multiplicative inverse and divide by 1 plus T. Okay, so that cancels that out. So now we have something with V equals TU minus U over 1 plus T. Oh, happy, happy joy. We have V isolated. So now we're going to put in what U was. So U was 18. We had originally. So we have U equals 18 and T equals 5. So we have 5 times 18 minus 18 over 1 plus 5, because T is 5. Okay, so 5 times 18. 5 times 8 is 40. Carry 1. 5 times 1 is 5 plus 4 is 90. Minus 18 over 6. So now when we subtract that, we have V equals, that's going to be, if I subtract 10 from 90, that's 80, and 8 from 80, that gives me 72 over 6, and that's 12. Another happy day. That's an easy one, an easy number, 12. Okay, so that's how we find a variable when it's not in a very nice place. Okay, we have to rearrange the equation. And it's not pleasant, and we have to take it step by step. And if we get stressed out, we take deep breaths, okay? All right, so now we're going to change the subject of the formula. And the subject is the isolated variable. Okay, so that's what they mean when they change the subject of the formula. Fancy new word, eh? Okay, so we want to change the subject to U. Okay, so that means what we're going to do is we're going to start with the original equation, S equals UT plus 1/2 AT squared, and we're going to move this over using an additive inverse. Okay, so if it's a positive half AT squared, we use a negative half AT squared. Okay, so when we get that, we have S minus 1/2 AT squared equals UT. So we still don't have U by itself. It's being multiplied by T. So we're going to divide everything by T. So I'll just divide it by T down here. Sorry, I'm running out of room. I should have used. Let me transfer this so we have a little more room, because that's a good idea. I agree. All right, so B is going to be A equals 6, S equals 203, and T equals 7. Okay, got some room now. Let's rewrite this line. Okay, so all right, so this is S minus 1/2 AT squared, and then we had UT. So the U is being multiplied by the T, and we want U by itself. So we divide by T, which is its multiplicative inverse, and we divide this by T. So at that point, we finally get U by itself. So we have S minus 1/2 AT squared over T. Okay, so now we can go put these conditions in that they gave us in B. Okay, so we have U. We don't know what it is, but we do know S is 203. Hey, these look like the same numbers we used in another problem. And A is 6. In fact, it looks like it is the same one. So we know what this is going to be. And then T was 7. All right. That's odd. I see. I accidentally switched up the examples. Oh, well, at least you get to see it again. Okay, so 1/2 6 is 3. 7 times 7 is 49. And we have 7 here. Okay, so we had U equals, and then since we did this already, let's see what it was. Where was I going to have to multiply that out again with a dry erase calculator? Okay, so we have 27, 147. Okay, so 203 minus 147 over 7 equals, and then 203 minus 147. So we borrowed 1, we had a 10, took 1 away, that's a 9. So we have 56. So that was 56 over 7 is 8. All right. So U was 8. So that's just changing the subject around from one formula to another. Okay, let's get that in order so that doesn't happen again. Okay, so on this one, this is actually example 3 now instead of 4. So example 3, we're changing the, we have the subject now as S, but it says make the subject R. Well, okay. So we're going to put a 1 under R, and we have K and 1 plus R over 1 minus R. Okay, so we're going to do a cross multiplying. So we have S times 1 minus R, and then 1 times that is just itself. 1 K times 1 plus R. Okay, so we are trying to get R by itself. So it's on both sides, which is going to make it interesting. So we distribute. So we have S minus RS equals K plus RK. And then we're going to subtract the K's from both sides. And we have S minus K minus RS equals RK. So we add RS to both sides to get the R's in one spot. Okay, so once we've done all that, we get S minus K equals RK plus RS. They both have an R, so we can factor that out. So we have R times K plus S. And now R is being multiplied by the quantity K plus S, so we use a multiplicative inverse and divide by K plus S on both sides. And then we finally have an answer. So we have R equals S minus K over S plus K. And I can just move this around from K plus S to S plus K because of the additive property of equality. Remember the multiplicative property of equality? There's an additive one as well. All right. So that would be my answer for changing the formula. Now, one of the things it did say in the beginning, it said R can't equal 0, and I just glossed over that. And that was a bad thing to gloss over. So if R was 1, I would have 1 minus 1. So what is 1 minus 1? That's right, it's 0. Can we have 0 in the denominator? That would make this, if that was 1, that'd make this 2k over 0. Well, that would be undefined. Okay, so you can't have R equals 1. So that's why that condition was there right in the beginning. So you always have to be careful when you're using letters, what's in the denominator and what would make that 0. Because that's not going to work. Okay, it's going to make it undefined. Oh, look at this. What a joy, huh? So this is really example 4, not example 5. Okay, so here we go. This one says, currently the subject is S, but they want to make the subject H. Oh, it's hiding in a square root with a square. Oh, this could be interesting. So we're going to take S equals pi r, and we're going to take a square root, and we have h squared plus r squared. So the easy thing to do is move this pi r over to the other side. So let's just divide that away right now, so it's out of the picture. So that cancels. So we have s over pi r equals, and then we have the square root h squared plus r squared. Wow, we have to get rid of this pesky square root house, don't we? Well, the fancy ninja math move to get rid of a square root house is you go and you put parentheses around it and you put a square. So if you do that, you have to do that to the other side. So we're going to square both sides. So what we get from that is s squared. Now we have s, I'm going to move to a new board. This will take some space, don't you think? Okay, so we have s squared over pi squared r squared. Well, that's just as beautiful, isn't it? But this is freed of the radical now, the square root, because I squared it. So I have h squared plus r squared. Okay, so our goal is to get h by itself, so we're going to subtract r squared from both sides now. Okay, normally when I square something like this, I would put a positive or negative sign, but I have a square root and it can only be a positive number, so I'm not going to worry about positives and negatives. So, okay, so I have s squared over pi squared r squared, and then that's going to be minus r squared out here equals h squared. But I want h, so now I'm going to use another ninja math move to get h squared to be just h. This time, instead of squaring it, I'm going to take a square root, and I'm square rooting this whole side here. So my final answer to get h as the subject, this is just going to equal h now. So I have h equals the square root of s squared. Oh, and this one we do need to have a plus or minus sign, because h squared could have been a negative number squared. So this is when it's really important. You have to have h equals plus or minus right there, because h could have been a negative number times a negative number, but it was squared. But now we freed it, so that means we have to plus or minus sign just to add a little more difficulty, as if this wasn't enough. So we had pi squared r squared minus r squared, and there you go. That's how you change the subject. And if you need to watch this video a few times, that's okay. This was a really, really hard problem. Okay? You have a wonderful day. Bye-bye.